Alrighty, welcome back, boys and girls. It's your main math man, Miss Shank, coming to you live from Summit Academy. In this video, I'm going to be working on that lesson number 4 from that unit number 8. Still talking about kind of side lengths and squares. And it says, what is the exact length of the side or the line segment? And then we're trying to find a decimal approximation of that length. So it gives you that this segment here goes from 0, 0 to 1, 1. Again, we can't say this is 1 because it's on the diagonal. So similar to what we did before, we can kind of draw that square for yourself. So let me do it in blue like we've been doing. So we're talking about finding this length here. And the way to do that is you can kind of continue drawing. We can say, well, if each of these is 1 by 1 square or grid, I can kind of let me try that again. I can kind of make it like this. I can say, if I have a tilted square like we've been working with, it'll kind of look something like this. And it's not going to be perfect, but that's okay. And then what I want you to do is I want you to try to draw that bigger square. So we have that outside square that kind of brings it all together, and what we can do is like we've been doing before, find the area of the large square. So we're going to find the area of the large square, so we're going to say area of this big square is going to be equal to, well, we know it's on its side, it's 2 by 2, so we're going to say 2 squared is going to be equal to 4. And then what we can do is we can say, well, also I know that I can find the area of each of these nice little triangles right here. So I have 4 of these triangles inside, so I'm going to say the area of one of these triangles is going to be 1 times 1, try that again, 1 times 1 divided by 2, which is the same as 0.5. So that means that each of these, or each of these little spaces, is 0.5. And so I can say there's going to be 4 of those, so 0.5 in each of them. And then I can say, all right, well, I know that the area of my tilted square, kind of looks like a diamond, my tilted square is going to be equal to, I have 4 minus, and I have to say, well, I have 4 of these triangles, so I do 0.5 times, let's do times 4 equals 2. So times 4 equals 2. So I can say, well, the area of this square inside is going to be 2, so that's going to be the area. However, I remember that the side length is equal to the square root of the area. So I'm going to say the side length is going to be equal to the square root of 2. So what I can do is just like I did before, draw the tilted square, draw the large square in purple, find the area of the large square, the small triangle, and then take the difference of those two to find the area of your tilted square, and then take the square root to find the side length. And what you can do for the decimal approximation is what you can do is for that part 2, so for number 2, I'd say use tracing paper. What you can do is you can find the length, you can find this length, and I can say, well, if this is from here to here, then I can say, well, it goes about the whole way, out to here. So I'm talking about, notice how this length is the radius of the circle. So that means if I look at the x-axis, I know it goes the whole way out to here. So I could say it's about what would we say, 1.4. So it's not going to be perfect, but we can say it's about 1.4. Alrighty, so then the part after that, it says estimate the length of the line segment to the nearest tenth. and then it says to find the exact length of the segment. So same kind of strategy. What I'm going to do is I'm going to draw let's draw our tilted square first. So I'm starting with this length here. And so I can say, all right, well, I know I go 3 to the right, 1 up to get my next amount or my next side length. So I'm going to go 3 up, 1 to the right, like this. And I know that this works out because I should have a square. So each of these side lengths should be equal. Again, on the picture, it's not going to be perfect, but at least you can kind of draw it out like that. Same kind of setup. Find your large square. So I'm going to find the area of the square like so. Again, we're going to say that if this is 1, 2, 3, 4, I'm going to say the area of this large square is going to be equal to 4 squared, which is 16. Find the area of these triangles. So I'm going to say area of this triangle is equal to, let me draw that triangle a little bit better. This triangle is going to be equal to, well, I have my side lengths of 1 times 3 over 2, which is equal to 1.5. Make sure you multiply it out. So I'm saying 4 of these triangles for these areas of the triangle is going to be equal to 4 times 1.5, which is equal to, should be 6. Yeah, equal to 6. So what I'm going to do is I'm going to say, all right, find my tilted square. I take 16, so let me say area of the tilted square, the diamond shape, is going to be equal to, draw one more time, about the same, is equal to, we say 16 minus 6, which is 10. So the area is 10, so that means the side length is equal to the square root of 10. So make sure you're saying, you gotta notice that difference between the area, which is 10, versus the side length, which is the square root of 10. So we can find that approximation. Again, use the tracing paper. Use that tracing paper. So use that tracing paper, kind of line up and say, well, if I kind of trace that along out, it should be about 3.1 units. All right. And that part number 3, we're talking about that square root of 3, and we're going to be trying to kind of estimate and use our approximations to the best of our ability. So it says Diego said that he thinks the square root of 3 is going to be approximately. So again, make sure you're seeing those little, I've used these a few times, but I want to make sure you're saying, again, that symbol is means approximately. Okay, so he says he thinks it's about 2.5. So then in the first part it says use the square to explain why 2.5 is not a very good approximation for the square root of 3. Find a point on the number line that is closer to the square root of 3 and then draw a new square on the axes and use it to explain how you know that the point you plotted is a good approximation for the square root of 3. All right, so we're going to say like this. Well, I know that in the previous one, or in the previous slide, so let's say, I kind of move this around. Let's actually move this around a little bit. I can write this first part. So part number 1, can write it anywhere. You could say part 1, we found the square root of 2 is around 1.4. Okay, and we found that in that first part of this page. So then we can say, so that means, so anything between 1.5 and 2 is going to be a better approximation, is a better approximation. So we're going to say, well, also too, if I think about it, if I look at, I can prove that this is not correct, because if I look at 2.5 squared, use that handy calculator for ourselves, 2.5 squared, that equals 6.25, which clearly if we had this squared, which is not, 3 squared, or the square root of 3 squared. To make sure if it was the square root of 3 squared, that would be equal to 3, which is clearly not 6.25. So we now have to have something that should be in between these two numbers. So let's kind of figure it out. Some things I do know. I know that we have, this is going to be the square root of 1. This is the square root of 4. Why my 4s always do that. So let's try 4. And this is the square root of 9. So you can use that number line or use that value for yourself. So that means that I know, and the reason why I said 1.5 and 2 is because I know that, hey, it should be in between, this space. So let's say that if this is, let me mark on here, let's say this is about 1.5, say that is about 1.5. Try writing a little bit better. Do 1.5 like that. All right. All right, so what I can do is this. So we said we know that 1 squared is equal to 1, and we know that 2 squared is equal to 4. And what I can do is kind of take in, when you approximate, you kind of want to make sure you're using some baselines that you know. So I know these two facts. And so what I'm going to do is I'm going to go in between 1 and 2. So I'm going to say, well, what's 1.5 squared? I'd say 1.5 squared is 2.25, which we're aiming for. Our goal is 3. So we're trying to get 3. So let's go a little bit higher. So let's say, well, what about 1.8 squared? What's that equal to? That's going to be 3.24, which that's a little too high, so it's not right either. So let's say that this isn't right, and we know that that's not right either. So let's keep going. Let's go a little bit lower. So let's say, what about 1.7 squared? That's equal to 2.89. So we're trying to get as close as possible to 3. So let's actually move another decimal place out. What happens when we say, what about 1.72 squared? What does that equal? It's going to give us some more decimal places. It should be closer to 3. So we have 2.984. Notice how it's getting closer and closer to, let's say, so this is closer to 3. So let's keep going. What about 1.73 squared? So this is going to be equal to, let's say, it's going to be 2.9929. So that's really close. So that's going to be probably our best bet right there. So we're going to say, this. So for that part number 2, so we're going to say for part number 2, if I can draw that number sign, we're going to say 7.3 or 7.7. Let's try that again. 1.73. There we go. 1.73 is a close approximation of the square root of 3. We can kind of draw that in there too. We said, hey, it's going to be in between 1.5 and 2, so let's say something in between here and here. So if we trace that out, I'm not the best of artists, but that's okay. What would that order pair be? Well, that would be the point 1.73, comma 1.73. So make sure you're seeing how to do this. Again, we kind of build it by knowing and using what we know. Use that number line to help you out and kind of build off of that. So you can try testing out some numbers. You're trying to get close to that square root of 3. And this is helpful. So I'm going to say this: use this strategy. Use this strategy for the exit ticket. Do the exact same thing. That way you can see how it works. All right. So now moving to the back. It says find the exact length for each line segment, and we try to estimate it. So we're going to say, I'm going to just use that strategy that we've been doing before, draw the big square, and what I can do is I can use two different ones. So I'm going to say, I'm going to do this line segment AB first. So I'm going to say this is our line segment here. What I can do is I can kind of trace out and draw our other side. So let's say 4 left, 1 down, 1 left, 4 up. Now I can connect those side lengths like so. So draw the tilted square first. Draw your big square next that is around the outside of these tilted square. So we're going to say the area of this tilted square is going to be 5 squared, since my side length is 5. So I'm going to say my area of this purple square is 25. Find the area of your small triangles in here. I'm going to say my area of my triangle is equal to, let's say, 1 times 4 over 2, which is equal to 2. Since we have 4 of those triangles, just like we've been doing, multiply the area of those triangles together. So it's going to be 8. And we can say the tilted triangle in blue, the area of that is going to be equal to 25 minus 8, which is 17. And we're trying to find the side length, so we're going to say that side length is the square root. So we're going to say that segment AB, the segment AB is equal to the square root of 17, which is going to be approximately 4.1. Or let's say about 4.1, since 4.2 squared is 17.64, which is too much. So we're a little bit too far. So we want to be as close as possible to it. So we can say, this would totally work. So I'm going to start a new one. You can use that same picture that you drew. Again, draw the big square. Draw the triangles. Find the side length. So I'm going to say, so now for this GH is your turn. And so what you're going to do, I'll set it up for you. Let's draw it out. So I'm saying this is, I go 4 by 4. So I'm going to count 1, 2, 3, 4, and 4 up. Like so. Same idea. Let's do 1, 2, 3, 4, and 4 up. 1, 2, 3, 4. Again, you should have a square when you draw it out. If it's a little leaning the wrong way, then you know you messed up. So let me do something like this. To draw that tilted square, you're trying to find the area, or try to find the area first, then take the square root to find your segment GH. Again, draw the big purple square, find the area of that, and subtract. Again, when you calculate that square root, again, find the side, again, as a reminder, the side length is equal to the square root of your area. So try that out. Again, pause at this time, try that out. Let me know if you have questions. All right. So now for number 2, it says plot each number on the x-axis. It says to consider using the grid for help. So real simple. I can say like this. I'm going to say, well, I know the square root of 16 is on 4, so that's square root of 16. Real easy. That one's good. What about the square root of 35? Well, I'm going to say square root of 35, use that calculator, or you can kind of estimate. I know that the square root of 36 is 6. So I can say, hey, it's going to be real close. It's going to be real close to it. It's not going to be on 6. It's going to be to the left. It is to the left of the square root of 36, which equals 6. So I can say this is going to be square root of 35. So same idea. What about the square root of, let me still use green. Sorry, there we go. Square root of 66. Well, I know that 64, square root of 64 is 8. So I know that the square root of 66 is to the right of the square root of 64, which equals 8. So I'm going to say it's going to be just to the right of that number there. So square root of 64. Nope, 66. There we go. So place those values on the number line. Again, use those perfect squares to help get you adjusted. For number 3, it says use the fact that square root of 7 is a solution to the equation x squared equals 7 to find decimal approximation of square root of 7. And we're going to say it's going to be in between these two numbers. So in between 6.9 and 7.1. So similar to what we did, and you'll use the strategy for the one on the X ticket. We're going to say, well, what do I know? I know that the square root of 4 equals 2, and the square root of 9 equals 3. So my side length is going to be in between these two numbers, and we're going to say whatever we have squared. So our value squared is going to be in between those two numbers. So let's try some of these out. So if I said, let's try 2.5 squared, that's going to be 6.25. Need a little bit higher because we're trying to get past 6.9. So what about let's try that again. 2.6 squared is 6.76. We're getting closer. Let's keep going. So 2.7 squared is equal to 7.29. So we know it's in between these two. So let's kind of go in between those two. Let's say 2.65 squared is equal to 7.0225. And so you know what? That's pretty close. That is in between those two. So we're going to actually say that, hey, right there is our approximation. So in between those two is what we're looking for. So we're going to say let's say the square root of 7 is going to be approximately, let's say, about 2.65. So that's close enough for what it's asking. And lastly, it says the points 12.23 and 14.45 lie on a line. What is the slope of the line? So recap from before. So recap from Unit 3. Again, remind yourselves of what slope means. We're saying like this. We're saying slope is equal to change in y values divided by that change in x. So let's write our 2 points that we have. So I'm going to say I have 12.23 and I have 14.45. So find my change in y. That's going to be plus 22. Find my change in x. That's going to be plus 2. Write it as a fraction. So I say my slope is equal to 22 over 2, which is equal to 11. So again, real simple. Have your 2 points, write the ratio, and simplify. Be sure to ask questions, and as always, super slam that subscribe button.